Finally, the last video of the collections, that is stream, right? So this is very important topic. I will cover the whole stream into the one video, and it is important from the interview perspective as well as it is very important from the day-to-day usage perspective also. So let's jump into that. What is a stream? We can consider the stream as a pipeline through which our data element passes through. So consider this as a pipeline, right? So let's say this is our pipeline, right? And we have data coming to this pipeline, and it will pass through this. While element passes through this pipeline, it can perform various operations like sorting, filtering, etc. So what we will have is we can put operations here. Let's say sorting operation, filtering operation. So what we can have is, in this pipeline we can add multiple operations, right? So as data passes through this pipeline, it will pass through all the filters and ultimately we will get the result or output, right? So this is very, you can say that just to imagine as what is a stream. So useful when deal with bulk processing, right? Because it has the capability to parallel processing. So I would say that the real power of streams comes for the bulk processing. If you have a collection with data, let's say 10, 15, either you do it processes through if else, for loop, or using a stream, you won't see much impact. But the real benefit of streams comes when we deal with a bulk data. So here if you see this diagram, a stream has three parts or three steps. So here we have a collection. So just say that collection of data or data. So in this collection, it could be your list, it could be your array, right? So just imagine a collection of data. Okay. So what is the step one? So in the step one, out of this collection of data, we have to first create a stream. So this is the step one. We have to first create the stream, because you might have data in an array, you might have data in a list. So first is we need to open a stream or create a stream. Second is intermediate operation. Add the operations. Add this operations, right? So these are known as intermediate operation. Why? What does it intermediate operation means? Intermediate operation like filter, sorts, maps are used. So what makes intermediate operations the name intermediate, right? So these operations transform the stream from one into another stream. Okay, so what does it mean is that this is a stream, you have opened the stream. Okay, you have opened the stream, now data is coming. So what it will do is, when it pass through the intermediate operation, the output is again a stream only. So that's what it says, that these operations transform the stream into another stream. So maybe at this point of time, this data is in for example unsorted. Then what is the first step? First step, I create the stream. So stream is created, right? Stream is created. This is unsorted data. So first step, open the stream or create the stream. So I have created the stream. Okay, the second step, put the intermediate operation. We can have an intermediate operation like sorted. This is sorted is one intermediate operation. So this sorted intermediate operation accept the stream, and its output is also an stream, but it transforms. So here it accept an unsorted data, output is sorted stream of data. Okay, so that's why it's the name intermediate. It's just not a final phase, it's just an intermediate, and we can have many intermediate phases or operation. I can have here, like say filter. Filter is one more intermediate. So maybe I can filter some data, let's say out of this unsorted integer, filter the data which is greater than 3, right? So it accepts this stream of data, it output would be also a stream of data, but it transforms it. So this has sorted, but values also lesser than 3. But after this filter operation, it will have all this stream of data which is only greater than 3 only. So you got it? What does intermediate operation means? They are lazy in nature. I will tell you what does lazy means, but just for now, see that these are lazy in nature. Means these operations get executed only when terminal operation is invoked. I will tell you with an example. But keep this in your bag that yes, they are lazy in nature, means they get executed only when terminal operation is invoked, right? We'll see in some time. Okay, so step 1 is clear that it is help us to create a stream. Second step is we can add one or more intermediate operations. The third step is terminal operation. Terminal operation you can use only one. So let's say you can use terminal operation. Terminal operation means as soon as the terminal operation is invoked, right, means you will get the result. After it is invoked, you will get the result. You cannot add any more operations after this, because terminal operation you will get the result and it will close the stream also. It will close the stream, right? So assume this, that this is your data. First step, you open the stream, you added certain operations, intermediate operations, many, but you added also one terminal operation at last. So after this terminal operation, we cannot add any more operation, whether intermediate or terminal, whatever, because after this terminal operation, it will output whatever the result would be and it will close this stream. Close the stream, right? And now if you see that this original data is not changed, it is not changed at all. It's never get touched. On touch in the sense, this do not get modified. So it always, each an operation, whenever they get stream is opened, they will get the data, they will output as a new stream, right? And whatever the result you will get, it will just, you can get that as a new, maybe list, maybe array, but it's a totally new data, new collection. The original collection is not changed at all. Okay. So step 3, terminal operation are like collect, reduce, count, etc. We will see that these operation triggers the processing of the stream, right? So that's what we call the intermediate operation as lazy, because they only get invoked when terminal operation is triggered. We will see that with an example. It also produces the output, means after terminal operation used, no more operation we can perform. Okay, so for this stream, 3 steps are there. Let's see with an example. So I am creating first an example without using a stream. So let's say I have created a data first, list of an integer which is nothing but a salary. So 3000, 4100, 9000, 1000, 3500, some salary, right, integer. Now what I am doing is, what I wanted to do, I have to iterate over this salary and I need to find out a count how many salaries which are greater than 3000. I need a count of that. So it's a very simple for loop. I am iterating it. If salary greater than 3000, count plus plus. So it should be 1, 2 and 3. So output should be your 3. But now if I want to write this using a stream, how I will write it? So the same, so you have a data, whatever the same data we have. Now instead of this, I am replacing it with a stream. So see how I am writing a stream. First, what is the step 1? From this data, you have to create a or open a stream. So here, from the list dot stream. So this collection has exposed a method stream. So this will create an stream, right? So first step is it will create a stream. So we can see also here that like so whatever the list would be, right, inside a list, let's say we have so it might be into this upper class collection. So do we have a stream? Let's yeah. So this method get invoked, and see what it will do is it will return the stream of whatever the data we have integer. So first step is open a stream or create a stream. So from this data source I have now created the stream. Now second is you can put one or more intermediate operation. So let's say I want to do a filter. So here I am doing a filtering, right? If salary greater than 3000, count plus plus, right? So salary greater than 3000. So this is filtering. So I am doing a filter. Dot filter. Don't worry about this, what all methods are present and how to use that. For now, concentrate that second step is the intermediate operation. So this is one of the intermediate operation. So filter, and you already know that lambda expression, it extensively use the lambda expression. So filter, so it will put this lambda expression that salary greater than 3000, right? So what it will do is it will filter from this stream whatever the data it is going through this second intermediate operation, it will filter out and keep only those which are salary greater than 3000, right? And this is the third step, is the terminal operation. So I did dot count. So count is one of the terminal operation. Again, don't worry about what all operations are there, how to use it. Just see that this stream has 3 steps. Open a stream, we can add one or more intermediate, and that is also not one or more, I would say that 0 or more. So it is not mandatory to use intermediate operation. So 0 or more intermediate operation, and after that you can put at least one terminal operation. So count I put it. So after this filter, whatever the stream has, because this filter have also have output the stream. Now this stream has whatever the data, right? So now here the next is count. So it will count it. So what it will have? 1, 2, 3. So its count would be 3. So here it should print 3. So in both the cases output would be total employee with salary greater than 3000 is 3. Okay. So don't worry about this filter, count and all. Just what I wanted to tell you about this step, 3 steps. So 3 steps should be at least clear to you. That first step is create a stream from the data source. Second step is 0 or more intermediate operation. Third step is you have to have one terminal operation, right? And that will actually return the output. Okay. Now let's come into the picture. What are the different ways to create a stream? What are the different ways to create a stream? From collection. So now let's say I have created a list of salary, right? So I have created a list, array list, simple, right? So from this list, if we wanted to create or open a stream, we can create that dot stream method. I have tell you that the collection has this expose this stream method. We can call that and it will give us a stream of integer, right? Second is from array. So let's say if your data source is an integer array. So this is an integer array and then you have the data. Now if you wanted to create a stream, how you can create it? Like this, arrays dot stream and give the array. So this will give you a stream of integer again. So arrays dot stream, you can use it for integer array or array, actually string array, whatever it could be, array, from array. Then from with the help of a static method. So here if you see that we can use stream dot off. and then you can put all the values here, right? So stream is a class. Here inside this stream there is a method called of. You can put a value there at like whatever. So here we will see that it should have of method here. So right, so it will take a of method, and through which you can put all the values which you wanted. You can put it in here, right, and it will create a stream out of it. So third one is from static method. So this is a static method of, right? So this is the one actually we have used the variable arguments one. We can provide a list kind of this thing. This is a variable argument, right? 3 dots. 3 dots 1. Okay, from stream builder. So there is like a method called there is one design pattern also, if you remember from the LLD, right? Builder pattern. So here from the stream you can create dot builder method. So it will give us a stream builder, stream dot builder object. Now what we can do is we can add a stream builder dot add whatever the values you wanted to add, right? After that we will do a stream builder dot build. It will give us a stream. So this is another way of creating a stream. Another way is from the stream iterate. So there is a stream dot iterate, right? There is one more method expose iterate. So this first one is the starting point. So let's say I wanted to start from 1000. After that is how you wanted to increment. So I wanted to increment like n plus 5000. So like 1000, like 5,000. So it would be 6,000, then 11,000, then 16,000, right? So generally this is the start point, and this is like another is like how you gonna perform or how you want to increment that value, right? So I want to increment like plus 5,000, right? Now this is generally we call this as an kind of an infinite iterate. It will keep on running. So we have to somewhere stop, right? So that's where we have to always use it with dot limit, right? So here what we will do is dot iterate, starting is 1000, incremented by 5000, and how much we wanted, dot limit, limited till 5. So 1 2 3, then it will do this, then this 5, 1 2 3 4 5. So this it will create a stream of this, a stream of integer like this. It will create using the iterate. So iterate is generally it will keep on iterating. So where we have to stop, it has to be stop defined by this dot limit. So iterate has to be used with the limit. Okay, so these are the different ways through which we can do step 1, create a stream. Okay, now second step, what are the different intermediate operations exist? So we can chain multiple intermediate operations together to perform more complex processing before applying terminal operation to produce the result. That's why I told you 0 or more intermediate operation can be put together. Okay, now let's see that intermediate operations which are present, right? Very important. So first is filter, right? So here I am creating this stream dot off using a static method. So let's say I've created a stream of hello everybody, how are you doing, right? So it's a stream of a string. Okay, so what is this? So I got a stream, right? Now the second step which is we are doing is intermediate operation. So out of this stream, for intermediate, input is a stream, output is also a stream, right? And this is like intermediate operation. So intermediate operation here is filter. So input is a stream dot filter. This is an intermediate operation. So now let's see once the filter part here. filter method, where it goes. Yeah, so this method is taking this predicate, right? This is the functional interface. And what does it take? So this is the abstract method, right? And it accepts one parameter and return whether true or false, right? So this is the predicate which it takes. So here it accepts one input parameter, and what it has to do, I am putting a condition here, name, whatever the name. So it will first this, right? So inside this filter, what it will do is it will iterate. It will iterate over your collections or streams. It will iterate over your stream, and what it will do is it will call that predicate. It will call that predicate, and this predicate has one abstract method which accept one value, right? So this filter method will iterate over this values and pass it to the predicate. So first it will pass hello. So the name would be hello, and what it has to do is that name dot length less than equals to 3, right? If it is less than equals to 3, then it would return true. As the predicate, we see that it should return true. And this filter method, what it does is, if it become true, then it will add it into the next stream, right? So here less than equals to 3, true. So what it will do is it will add it into the stream. So next, everybody, is it greater than equals to true? Less than equals to 3? No. So it will not get added into the stream. Hello will also not get added. How? Less than equals to 3? Yes. So this is currently added into the stream. R also added into the stream. U also added into the stream. Doing? No. Okay. So the output of this is also an stream. This is also an stream. Okay. After this, what, to get an output, we need a terminal operator, right? So terminal operator is, there are so many. So this is just one. So I'm collecting this data in a list. So this dot collect. So whatever the stream is there, I am doing dot collect, right, to a list, and it will give me the data into the list. So now if you print that data, what it would be, how are you? These three things will get there in the list. Okay, so this is the function like filter, which can be used to filter the element. Second is map, right? It is used to transform each element. So here if we see that, first map. Okay, so this map is using which function interface? Function. And this has, so this is a function interface. So function interface has one abstract method. So this abstract method accepts one value and also return also, right? So first I am creating a stream. I am opening a, so this is my step 1. I am creating a stream. Hello everybody, how are you doing? Same example. Now I am doing dot map. I am putting an intermediate operation dot map. And in the dot map, internally what it will do is it will iterate over each element. It will iterate over each element and it will call the predicate. So here in this, if you see this, what it will do is it will iterate. It will iterate and call this predicate, right? And it simply put it into the downstream. Downstream is like whatever the stream it is creating. It is added a new stream and it is keep adding the data into the stream, which will go down. So it will iterate over each element and it will pass it to the predicate, not predicate, it will pass it to this function interface, to this one, and we will define what we have to do. So it accept one parameter because it will pass this value, right? So string name, what I have to do, I have to make it like I make it a smaller case. So it will return this, right? Name dot to lowercase, it will return that one. So it was added into, collected into a stream. And again, after that, if you do collect and print it, what it would be like, hello everybody, how are you doing? But if you see, everything is in a smaller letter. So when it input is, everything was capital, and after this stream or map function, everything is smaller. So it is used to transform each element. Okay. The third one is flat map, right? So this flat map is like, I think we already know the flat map, right? What does it does? So if you have a complex collection, like I have list of list. So let's say you have a complex collection like this, list of list, and this is also have a list. This also have kind of this. So you have like 1 2 3 4 list of lists, right? 5 6 7 8 9 10 11 12. So what it will do is flat map. It will just make it flat like it. So if you put this into a stream, and inside a flat map intermediate operation, what, so output would be a stream of, let's say these are integer, so a stream of integer. It just make it flat, 1 2 3 4 5 6 7 8. Now it will not be a list of lists, it's just a values, a stream, like a stream. Then we can collect in an array or list or like that. So for this I have created a list of a string, right? So here I have list like I love Java, then concepts are clear, then we have it's very easy, like this. Then what is the first step is? The first step is get the stream from your data source or collection. So from this source list I have opened a stream, created a stream. Now second is putting an intermediate operation. So this is my second step. I am putting an intermediate operation, that is flat map, right? Here I am putting a flat map, and here let's see that what flat map accept. So flat map is accepting, so it would be inside this flat map. So flat map is also accepting the function only. So it will accept one parameter and it will return the output, right? So here in the flat map, so it will iterate over each element of this list, and it will pass each element to this functional interface abstract method. So each element is nothing but a list of a string. So list of a string will go, and what I have to do is convert each of them to a simple sentence. Whatever the list is, I'm converting it to just a stream, right? Converting it just a stream, right? So it will just goes to the flat map, and internally flat map just simply add it. So here if you go there, right? So here what it will do is it will call each like this, right? And each element it will pass it to the functional interface. So functional interface is accepting lambda expression one parameter, and what I am doing is I am just returning its stream. So its stream would be like I love Java. So this is return its stream. Then second it will go, it will pass its stream. So what flat map will do is flat map will just create one more stream, and it keep adding on top of it, like it will keep appending, right? And after all is done, it will have just one stream with all the values. So what would be the, if we just do like this collection to list, if we take it in a collection and print it, so it would be like I love Java, concepts are clear, it's very easy. It's like this only. There is nothing like list of list something. It's just a list of string, right? So that you can do. And also one more thing, you can use flat map also. Like let's say the same example, right? I have first step converted to a stream, second using flat map, while iterating over each element in the functional interface, right? So here for this sentence, whatever this, I have to make it a stream. So I have, because this is a collection also, right? This is again a collection. So for I am creating a stream out of it, right? I am creating a stream. So what it will do is I can also change this value. So it was earlier capital I love Java. So I can also perform more intermediate operation inside this, right? And I change it to lowercase. So whenever it is returning the stream, so while small lowercase letter, right? So that is also you can take advantage of flat map, right? So here if you see, I got a single stream with all small case, right? So inside a flat map, when this functional interface method got invoked, right? For this list, I have created a stream, like just a sequence of strings. I can even add intermediate operation on top of it also. Cool. So used to iterate over each element of the complex collection and helps to flatten it. Then we have distinct. It removes duplicate from the stream. So let's say you have an integer array which has certain duplicate. Now we have to remove it. How? Using distinct we can do it. So arrays.stream. So this is the first step to create a stream out of an array. Right? Second is putting an intermediate operation. So I am using a distinct. So what distinct will do is internally it will iterate over each element and perform a logic to remove the duplicate. So output of this would be a stream without duplicate elements, right? So here I got a stream. If I put a terminal operator and get it into a list and print it, I will get this, no duplicates. Similarly, a sorted, as the name says, that sorts the element. So I have an integer, I created a stream and then put a intermediate operation, sorted. So its output would be again a stream only, but the sorted one, 0, 1, 2, 2, 4, 4, 5, 7, 9. Earlier this one unsorted, this is sorted, right? So here you can also use sorted, and you can also put a comparable you can provide it. So let's say if you want to sort in a descending order, right? So you already know that how comparator works, right? So you can do val2 minus val1 inside a sorted, so it will sort in a descending order. So there is another called peak. So what peak will do is nothing, like here it do consumer. So what consumer does, let's say that peak. So what this, so it inside a peak it will iterate over each element. It will iterate over each element of the stream, and it will call this consumer. It has one method, so it will accept one parameter but doesn't return anything. So here, so this is the list. I am creating a stream, step 1, and they are like intermediate operation, right? So let's say this is, I am doing filter value greater than 2. So here it will filter like value greater than 2 would be 3, 4, 6, right? Then here I am doing peak. So peak accept, iterate over each element, and for each value it will print, because it is not returning anything, right? System.out.println, it will print, right? So you can use it for printing, peaking, right? Then another is limit. So limit is you can always limit out of this stream how much truncate the stream to no longer than the given max size. So now let's say this is a list. I have first created a stream out of it, but I want to truncate all the data out of this stream and only want to keep the 3. So what it will do is limit, I can put limit 3. So it will just put this 3. So whatever the stream it will return, it will have only 213. Now I can put terminal operator, take it out on a list and print it 213. Similarly, we have skip. Skip the first n element of the stream. So you have a data, create a stream out of it. Now this intermediate operation skip, so it will skip first 3. So from the stream, so it will have this stream which will have 4,6 only. If we put a terminal operator and print it, 4,6 will be there in the stream. And then there would be map to end. So here this is also another important thing, is that here let's say helps to work with the primitive int data type. There would be like map to long, which helps to primitive long data type. So for example, let's say you have, let's say, see this example first. Let's say you have an integer array, but this is primitive data type, right? Primitive data type. Now you know that there for this primitive data type, how you can create a stream. So here we can create arrays dot stream, right? And put this integer array, right? What it will return? It will return us int stream. This is very, now here it is not returning us stream. It is returning us int stream. This is very, very specific for primitive integer data type, right? All other methods are same here, but only this thing is, this int stream is very specific for primitive integer, right? So here I have created, first step is I created a stream, but here in this case this is int stream. Now the second step, again the same thing, nothing got differ. I can do filter. Now see here, I can easily work on the primitive data types with the normal stream, right? With list of integer and all. If you are trying to do filter and all, you won't be able to use int over here. No, for that you need int stream, right? So with an integer array, when arrays dot stream, you can get an int stream, and then you can do filter, and you like this anyway normal it will work, but it can also work with the primitive data type also. So again another usage of the is, let's say you have list of string 2147, but these are the string. Now here if you see that the first step I created a stream. Now second, there is one method map to int, right? This map to int. So here inside this map to int, what it will do is that it will convert it to an string, right? So this map to int, it might be taking function only, map to int. So it will take this. So this is the functional interface. It will accept and return the integer, right? It return the integer. So it will accept anything, whether a string or any other value, because it's a generic type, right? So map to int will iterate over each element and it will pass it to this function interface, right? So for each element, what I'm doing is converting it to integer.parseInt. So I am returning the integer value. So 2147 now in an integer form. So now it is returning int stream, which is specific for integer, small primitive integer type, and I can convert it to array. This is a terminal operator, and I can get an array and print it. So map to int is for, you got it right. Map to int is like, you can use this like convert into an integer, like this one use case I have showed you. Similarly, map to long, map to double, can you try it and post into the comment section one use case which you are using it. So here these are the 10 11 most frequently used generally intermediate operations I have showed you, right? But now you might be asking, right, hey Shah, you were saying that they are called as lazy. Why? Right? Now let me show you an example. So here I am creating a normal simple class stream example, and this is the main method. This is just my collection list 214710. Nothing, no difference, right? So first step I am doing is from this collection I am creating a stream. Second is I am putting an intermediate operation filtering this data. After filtering I am also doing peeking, and while peeking I am printing this value, right? I am printing this value. So this is, I haven't used terminal operation yet. So peek is again a intermediate operation. So output is again a stream. Now I am running the code. When you run the code, what output you will get? Nothing. You won't see anything in the output. You can say that, hey Shreyansh, why? Because so you can say that, right? Hey Sham, why I haven't seen anything? Numbers dot stream. I have opened a stream for this number 214710. I have done a filter greater than equals to 3. So this should have returned the stream which is greater than 3, 4, 7, 10. Then I am doing a peeking intermediate operation where I am putting system.out.println. So it should print 4, 7, 10, right? It should print 4, 7, 10. Why it is not printing? So it is known as lazy. And when I say that lazy means this streams get only executed when terminal operation is invoked. So now the same thing, but now for this stream whichever I got, now I am calling the terminal operation. Numbers stream, I am putting a terminal. This is count, is one of the terminal operation, count. So what is the count? 1, 2, 3. So 3. So now at this point of time when it is terminal operation is invoked, this stream actually start running, and it will see, you will see the output system.out.println val 4, 7, 10. So this is the input to the peak, right? So it will print 4, 7, 10. So that's why it is known as lazy. Now I will tell you one more very interesting property of the stream. You will see that, hey, what's happening, man? Like this is something new. So sequence of stream operations. Okay, see this. Okay, so here till now this is very basic. I have written whatever we have studied till now. I am creating a stream out of this list, nothing new. So I have used a filter, then I am doing peeking, then I am doing mapping. Whatever the value comes after the filter, I'm just negating it. Then I am again peeking system.out.println. Then I am sorting it and again peeking it. So this is the stream, right? And this is the terminal operator I have put so that this stream should get run, right? Now what is the expected output? So my expected output should be what I am expecting, how stream should be working. So let me have visually have this, like first I have created a stream. So it would be like I have all the values 2, 1, 4, 7, 10. So a pipeline got created, the stream got created. Now first is filter. So first barrier is filter. Greater than equals to 3. Greater than equals to 3. Right? So my expectation is first when this stream pass of this barrier or operation filter, so its output will also be an stream, right? So what it will do is it will filter only greater than equals to 3. So 2 will get removed, 1 will get removed. So 4, 7, 10 would be there in the filter, right? So this stream has 4, 7, 10. The second operation is peak. So this is peak. So in peak we am just printing out after filter what are the stream. So 4, 7, 10. So it should print system.out.println 4, then 7, then 10, right? Then the next operation is map. So in map what I am doing is for each 4, 7, 10, what I am doing is I am negating it -4. So it will whatever the it is coming 4, 7, 10, it will put -4, -7, -10. It will do this. Then after that we have peak again. So I have peak again. So peak again I am just system.out.println after negating. So this is the stream is coming to the peak -4, -7, -10. So it will print that. So it should print -4, -7, -10. Okay, so this peak is just printing but nothing else. Then after that sorted. So there is one more operation. There is one more operation now. Sorted. So what was the stream which is coming? -4, -7, -10. So sorted with sort into an I am doing a increasing order, natural order. So it would sort like -10, -7, -4, right? In a increasing order it sorted it, converted the stream, and the last is again peak. System.out.println after sorted what is? So it will print -10, -7, -4. So my expectation is that when the terminal operator is invoked and this stream get executed, it should print this expected output. Whatever the expected output I have figured out, right? This is what my understanding till now is. But now let's see the expected output. You will also get little bit surprised to see that, hey, this is how the stream works. Let's see that one, right? This is very interesting. Okay. Let's see the expected output which actually is present. You able to see, right? So here, if you see the expected output, is it matching with our actual output? Does matching with our expected output? Hey, no. For first it is doing after filter, then after negating, but we are expecting like this, right? But here if you see, these are how they have printed, how they have worked. First it say after filter, then after negating, then after filter 7, after negating -7. How it worked? I'll tell you how it works. So here again let's say we have 6 operation, right? So we have filter, we have then peak, we have then map, then we have peak, then we sort, then we again peak. And what is the stream which first comes to is that 2, 1, 4, 7, 10. 2, 1, 4, 7, 10. Okay. So when now see how it works. So now what stream works is it pick one element. It pick one element. It give it to the filter, or when it passes through the stream, right, pipeline, it give it to the filter, right? So it will do filter. Hey, does 2 is greater than equals to 3? No, it's not. So this one is removed from the stream for the filter. Now it goes 1. Hey, 1 is greater than equals to 3? No, it is not. So again this is also got filtered. Then it comes 4. Then it comes here 4. 4 is greater than equals to 3. Yes. Right? Now it doesn't go, stream doesn't go like, okay, now it will goes to 7. It's not like. So what it will do is it will try to go as much bottom as possible. So after filter 4, it goes down to the peak, next operation. So it will print after filter, 4. Then it goes down to the map. What it do is -1. So it does -4. After that it goes to the down peak. It is after negating -4 printed. But here if you see that now it is going 7. After that it is not going bottom. Right? Why? Because there are certain operations, right, which can be run like this. But there are certain intermediate operations for which it required all the data to be present first, right? Like sorted. So sorted, first of all, the whole stream should be present. It cannot work on a partial stream. Like, so that's why sorted didn't work. Like here, after this 4 minus 4, 7 comes. So it picked the next element, 7. Right? So 7 is greater than equals to 3. Yes. So it will peak. So it will print 7. After that, it will negating it -7 inside a map. And then it goes to peak again. So it will do -7. But again, for sorting, it's not yet started because the stream knows that it has to have complete stream available for the sorted. So then it goes to 10. Yes. 10 is greater than equals to 3. Yes. It will peak it up 10. It will convert it to -10. Then it will goes to peak. It will print it -10. Now a stream has all the data. 4, -4, -7, -10. It will do sort. And then it will goes to peak again. One by one. So -10, -7, -4. Right? So you got it. What happened? So here it tries to one element. It goes sequentially. First of all, so stream goes sequentially, and it's not, and for one element, if this operation doesn't require all the stream to be all the stream elements to be present, it goes pass it to the next operation. It goes and check, hey, does you required all operation to be all elements to be present in the stream? No. Then execute me like this, right? So this is also added one more advantage to the stream. Like, so this elements processed sequentially can perform multiple operations like this, which are right. And this will give you one more advantage. For example, understand this use case. You have a huge list, let's say of 1 million elements, let's say huge stream. Now you have you have multiple operations, and you have one operation that return any value greater than 3. That's all. Any value, return true. Let's say I want to just return true if any value is greater than 3. Right? I have, let's say, 4. Now 4 is coming. Okay, passed, operation passed, and as soon as I said any value greater than 3, yes, 4 is greater than 3, it is stopped. So here if you see that even at the second it stopped, it doesn't have to process the complete stream at every step to start, right? But there are certain operations, like one of them is sorted, which required all stream to be present before itself, to start. But many operations are there which doesn't require all stream data to be present. So for individual element also they can work, right? So that's one of the advantage of the stream also. Now let's see one more. Now let's see different terminal operations we have. So currently we have seen 2 steps: how to create a stream, how to create what are the different intermediate operations. Now let's see what are the different terminal operations. So terminal operations are the ones that produce the result. It triggers the processing of the stream. So first is for each, right? So for each, perform action on each element of the stream. Do not return any value. So it's just like a peak, but it's kind of a you can say that terminal operator. So here I have a list of integer. So first step I created a stream. Second step I added a intermediate operation, not mandatory to add. You can skip it also. Then I am just printing it kind of for each element, for each value. It will just print it, because this is the one functional interface which accepts one value but doesn't return it, right? But since this for each is your terminal, so it will trigger the execution of this stream. So it will filter greater than equals to 3, right? So 4, 7, 10 will get printed for each with this one. Similarly, one more is to array. So here you have an list. So first step created a stream out of it. Second is adding an intermediate operation. Now what I want to do is I want to collect it, whatever the stream intermediate operation will return, I have to collect it. So when you do to array, right, it will return object array. So here inside a stream you have to array. So this is a terminal operation, right? Here it is written, this is a terminal operation, and it returning object array. But now you can ask that, hey, Sharon, like I wanted a specific value in specific data type array, like integer, string array. How to do that? You can do that. Like the first step, create a stream. Second is like intermediate operation, nothing changed. Now inside a to array, you can use another flavor where you are just asking that create this integer type. So here it take a size. So here it has one more flavor, to array, right? So it has a to array. The value is nothing but a size. This, right? The size. And output is your array. I am creating a new integer array of this size. Right? So you will get an integer array, whatever the stream data you have. Then another is reduce. So what this reduce will do? So here if you see that the first step, for this list I have get out a stream. Now what this reduce will do, does reduction on the element of the stream, perform associative aggregation function. What does it mean, associative aggregation function? So here if you see that 2, 1, 4, 7, 10. Let's say I want to add two elements. First 2 plus 1, 3. Then my data would be like this. Then 3 plus 4, 7. Then 7, 10. Then 7 plus 7, 14, 10. Then 14 plus 10, 24. So this is like associative aggregation function. Aggregation like sum, multiply, something, right? And associate like this. So first is done. It will become, now do with the next one. Then do with the next one. Now do with the next one. Okay. So with the reduce is a terminal operation. It accepts by binary operation. So here if you see that reduce, so binary operation is your, it's a functional interface, right? So this is not a abstract method, so it would be abstract method would be here. Okay, so it accepts two values, two parameter, and return one thing. So it accept two values and return one thing, whatever I wanted to do. I wanted to do value 1 plus value 2. So what it will do is it will pass 2 value out of this. 2 plus 1, 3. Then 3 plus 4, 7. Then 7 plus 7, 14. Then 14 plus 10, 24. So it reducing your stream by performing associative aggregation function. So now this is a terminal operation. You will get it return the optional return value, reduce value, integer. So when you print it, you will get 24. So optional means like it can be null also. It can be, you can check with reduced value dot is empty, whether it is empty or not. That it's just a wrapper, so that it, you can say that it's just a way to avoid null pointer exception. You can check is empty or not, right? but if you do dot get, it will return the value which has. So dot get, I got a 24. You got it right? Associative aggregation function. If I do value 1 into value 2, what it will do is 2 into 1, 2, then 2 into 4, 8, then 8 into 7, then like this. Then we have collect. I have already shown you the collect can be used to collect the element of the stream into a list. So you have a list. So first step, create a stream. Second is any intermediary operation. Then whatever, so intermediary operation returns you the stream only. So this is the terminal operation collect. I am doing collector dot to list. So it will help me to collect the stream data into a list. So I have a list now. Then there is something called min max, right? Finds the minimum or the maximum element from the stream based on the comparator provided. Very, very simple. You have a collection, you create a stream, added a filter greater than equals to 3. So means 4, 7, 10 would be generally should be there. When I do dot minimum, I am doing value 1 minus value 2. So means I wanted a natural ordering. So natural ordering like increasing order. So dot minimum would be return 4. Right? It return an optional this thing. Similarly, when I do value 2 minus value 1 means I sorted in a decreasing order. And when I do minimum, so it will return 10. So generally, if you see that, I would say that this minimum is the wrong name. I would say that the first in a sorted stream, whether it's a increasing order sorted or decreasing order sorted, it will get the first element, right? So 4, 7, 10 when it was value 1 minus value 2 means an increasing order. So dot min gives me the 4. And let's say if I have a minimum but I pass the comparator as value 2 minus value 1. Internally it will sort in a decreasing order. So it will give me the first element itself, 10. Right? Similarly, you can test for the max also. Then we have count. You already know that the count returns the number of elements present in the stream. So you have a stream, step 1, step 2, you filter out 4, 7, 10, dot count. So it will return 3. Now another is any match. Check if any value in the stream match the given predicate and returns the boolean. Right? So here from this list I created a stream. Second, see now here I have don't using any intermediate because intermediate I told you 0 or many. So it is not mandatory to use. I am using any match value greater than 3. So yeah, 2, 1, 4. Yes. So it will return true. Any. Right? So it will return true. Can you try this all and none? All means if all match the condition, it should return true. None means if none of the value match it, then only it should return true. It's very, very like simple. Like by knowing itself, we can know that behavior, how it works. Find first. Finds the first element of the stream. So here you have created the stream from this collection. I have filtered out the element. It would be 4, 7, 10. Find first, it will return 4. Okay. Find any will give you a random value 4, 7, 10. And if you do find any, it will return anything 7, 10 or 4, whatever. Find any random element to the stream. Okay. So we have seen how to create a stream, what are the different intermediate operation and what are the different terminal operations we can have. Now here I will show you one more thing. How many times we can use a single stream. This is also, you see that I told you a stream is created at this point, and at the terminal operation. So this is the terminal operation. This is the second step. So here, sorry, this is not the second step. So this is the intermediate operation, and this is for each is the terminal operation. So whenever this is the terminal operation. So whenever the terminal operation is invoked, a stream is get executed, and after this one, it closes the stream, or you can say that consume the stream. Now if you try to use this stream again, filtered number stream, I am trying to use this stream again, filtered number dot collect. I am trying to perform any operation. It returned me this exception: stream has already been operated upon or closed. Done. So once a terminal operation is executed, it closes the stream. It closes the stream which was started, right? After that, on this stream you cannot work more. So from this number or collection, you have to create another stream and then work on it. Okay, so just remember that one. On a stream, once closed, cannot be used. You have to create new stream. And at last, we have to see that parallel stream also. See, this is, to be honest, in last 8 years, I haven't used parallel stream. We have used lot of stream in our day-to-day code, but parallel stream is very less frequently used, but it's still from the interview perspective, it's good to know. So it helps to perform operation on a stream concurrently. It takes an advantage of the multi-core CPU. Parallel stream method is used instead of regular stream method, right? So before this going, let's see that. I'll show you an example. So here I have a collection. I have put a 11 table, 11 number table, 11, 22, 33 and all. Now this is the sequential processing, whatever we have done till now. So from this collection, I am creating a stream first, right? I am doing an intermediate operation. I am doing map and multiplying it with the number. So you can say that I am just squaring it up, right? So again, it would be output would be stream, and I am doing for each. I am just printing it out, right? And so before starting this stream, I have taken out the time, millisecond time, what was that? And after this invocation of this terminal operation, stream would get completed. So now I am just printing out that sequential processing time taken, current time minus this time before the stream started. So that will give you a diff, right? How much time it took, that much second. Now if I wanted to do the parallel processing of the same, what exact same code, but here if you see that first I have taken out the time, what is the current time, then I am creating the stream, parallel stream. So here if you see that from the collection we were doing dot stream. So this dot stream creates a sequential stream. For parallel we have to do dot parallel stream, right? So dot parallel stream, that's the only difference. So numbers dot parallel stream. So first step is we have created a parallel stream. Second step, same intermediate operation, multiplying it by this. Third is terminal operation and just printing out the value. And this terminal operation will execute this stream, parallel stream. And I'm printing out current time minus this parallel time diff millisecond. So here if you see that this is the sequential printed because of this sequential, and sequential takes 64 milliseconds. Now for this parallel processing, it will again print it out this value, right? Parallel processing time take only 5 milliseconds. See, it's faster. Why parallel processing is faster? Because it doing the task concurrently. How? It doing what it is, whatever the task is, it will divide into subtasks. Then subtask can be divided into more subtasks, right? And after that, each subtask can be run parallelly. It can be run parallelly, right? If you have, let's say, 4 core CPU, then on each core it can run concurrently itself, right? It can run concurrently at the same time, and then we can join the result. We can join the results and ultimately shows the output. So this is known as fork join pool technique. So parallel stream use fork join pool technique to perform the operation concurrently. In the fork join, fork means divide, join means whatever the subtask we have divided, every time fork is called, a task has been divided into subtasks, smaller tasks, and join, it joins the result. So this fork join I will cover into the our next topic, multi-threading, right? Because it's a multi-threading part. But parallel stream internally uses fork join pool technique to do this parallel processing concurrently. Right? So I will cover it into the multi-threading topic. So in multi-threading we have thread executor and fork join is also one more topic also. So here, if you see that parallel stream, just we see that I wanted to show you before we come. So parallel stream. So here in this collection we have parallel stream. Yeah. So whenever from the collection we are creating a parallel stream. So here if you see that it call a split iterator. Right? Here it calls a split iterator. And if you see this split iterator, I will go to array list something. Right? So here this has a split iterator has one method called try split. So let's go inside this try split. See this logic. What it does is this big task which we have, like let's say we have this task 1 2 3, let's say this is the collection 1 2 3 4 5 6 7 8 9 10. So what it does is when you call parallel stream, what parallel stream will do is it will pass this data to split iterator. Now inside the split iterator there is a method called try split. So what it will do is this split iterator has the complete collection now. So now what will happen is recursively it will call try split. So what it will do is it will find the mid, and after finding the mid what it will do is it will create a new split iterator. So it will split it 1 2 3 4 5 6 7 8 9 10. This is again now a split iterator. This is again now a split iterator. Now again on this split iterator is an interface. So there is a method try split. So you can again split it 1 2 3 4 5 6 7 8, let's say 9 10. So this is again a split iterator. These are all split iterator object. Now so who take the responsibility of splitting the task? It's the split iterator. Inside a split iterator there is a method called try split which takes out mid and split it, and this method has been called by parallel stream function, and it called recursively to divide into a smaller data. Now after the data has been splitted into smaller chunks, what parallel stream do is it will give this smaller chunks to fork join pool technique. Hey, these are the smaller chunk data, now you take care of it. You execute them into different concurrently, or if you want to divide it further, do fork it, do it like you wish. I have given you the smaller chunks which I wanted to execute parallelly. Now you try to run them parallel, right? So this is how parallel stream works. fork join pool, I'll tell you in the next topic, multi-threading. But this is all totally about a stream, right? From start to end. Any doubt, question, like please feel free to ping me in the comment section, team. And but with this, collection is completed. Multi-threading is going to be the next topic. Okay guys, thank you. Bye.